This is Jacob Blackburn and Lindsay Miller, and we're all seniors from Belfry High School, and we did this research for kudzu. Like I said before, basically all of our projects involved kudzu this year. It's the magical plant, might be involved in a lot in the future, but right now it's mostly just a nuisance. And so it's an invasive species, and it came from Asia originally, but it's been called the plant that ate the South. Because if you look outside, just like I said, in my own backyard, on your way to Pikeville or all across eastern Kentucky, it's everywhere, down throughout all the South, Alabama, Georgia, up into Virginia. And right now, obviously, it has no use. And so it's a plant that grows fast, rather without control, something that's more renewable than trees or bamboo or anything else like that. And it's biodegradable. It would offer a better, healthier alternative than plastics, bricks, woods, things like that. So basically, we don't have to kill trees for our building materials or our papers or whatever anymore. That's our ultimate goal. And also, like I mentioned before in the last project, kudzu offers something that it's both proven that it's feasible and it can be used to make something, but also hopefully it'll be cheaper. Hopefully it'll be more renewable, and it'll be a logical alternative for people who are in it just to make money, for corporations and businesses. And it's something that can actually be implemented in the future, hopefully in the next 5 to 10 years even. So our materials used right here, you can see in our picture, we started out with just a kitchen blender, kudzu blended and chipped, water, glue. And ultimately with our project, we started out by saying in our last fire summit that we decided we wanted to use kudzu to make building materials for housing for the homeless. And we came up with that hypothesis and that goal in the beginning. And then we started looking online, of course, as everyone in this generation does on YouTube and Google, for people who have done it before us. And we realized that no one had done it before. We saw barely any research with kudzu, and that's one of the things that got me really excited about this is almost groundbreaking. The fact that no one's tried to use it to build materials, and obviously we're not chemical or materials engineers, so we said, how do we do this? So we got out our blender, and we started out literally by just chopping up the kudzu, adding enough water in until the blender was able to process it, and we got a fibrous paste. And you can go forward a little bit and see here, we use both the small twigs and leaves in it, and those were able to just be ground up by the blender. But we also used the branches, which we put into this wood chipper that we purchased with one of our grants, and we processed it through multiple times until it was fine enough to be processed by the blender. And we started out just by making a small mold in a little piece of just a plastic cup from a toolbox with holes drilled in the bottom. And I made it with just kudzu mixed with water, sat it to the side for about 2 to 3 weeks. And I thought, oh, that's not going to harden into anything. It's just water and kudzu, same thing as mixing it with grass. 2 to 3 weeks later, got it out, popped the brick out, and I had an actual brick. We should have brought them up here to show, but it was a brick about this large. It could hold up to its own weight. You could squeeze it. It fractured just like a rock when we broke it in half. And so, it obviously showed us that this has potential to be used. So we went on forward. We bought this contraption you can barely see here. It's actually meant to be used to make paper logs and fire starters. You just take recycled paper, wet it into a paste, put it in, and you make these paper bricks that you can use in an outdoor fireplace or grill or whatever. But we decided that we could use that to put our kudzu mash into to form it into bricks, because that was our ultimate goal. It was the perfect machine that we found here. And so we just used that as a press rather than having to use a vise or something like that. And so we mix it together, and we have 2 bricks right here. One on the left is slightly darker, is just kudzu and water, and the one that is lighter is kudzu, water, and all-natural potato starch. So our ultimate goal here, obviously, is to make something biodegradable. So we couldn't do what's normally done in commercial processes involving all these synthetic chemicals and, names you can't pronounce. We wanted to use all-natural things that were both cheap and would allow it to be completely biodegradable, something that we could cook in a kitchen almost. And so we let each brick dry, we compressed it, got all the moisture out that we could, and then the individual molds for the bricks come out. And so we literally just put them in a toaster oven that we had bought to melt plastic in another project. And I started out the first brick, it was just water and kudzu, and I put it on a high temperature for a short time, and I realized that it charred, blackened, and fell apart in its own weight. So with that trial and error and experimental learning, I realized that you have to do it for a long amount of time and a low temperature. And so we have 2 bricks, large actual brick-sized bricks that hold on to their own weight. They can hold themselves up. They can hold up to compression. They don't completely fall apart when you pick them up. And this shows just basically the summary of all of our research. We used leaves and sticks, some of the branches. Here's one with potato starch. We did one test with glue on a tiny bullet, just in a plastic cup. And I didn't continue that, obviously, because I didn't want to use the glue because it wasn't an all-natural ingredient. And then you can see the days spent hardening. Basically, we just have to leave them for a week or two, over weekends for them to dry out as long as possible before we put them into the oven. Because obviously, the ultimate goal is to remove as much moisture as possible to prevent molding or rotting. So like I said, we've had various ranging of success, from burning bricks to making the first small experimental bullets to making the actual final products that you can see. We have them on showcase out in like the garage area. But ultimately, our bricks, they show potential. They show that they can hold their own weight. They can compress weight. And I'm in a physics class with Doc the period after the class that we do this research, and we plan on testing all the physical properties of the bricks. So the tensile strength, how much force they can withhold before it breaks apart or breaks down the middle. We want to use plate weights to see how much weight it can withstand before it begins to compress. And so within the next couple of weeks, we want to just continue this research. And this is research, like I said in the last project, that can be picked up by people who, can really continue this. This could go into industry. It could go into building. This could be used as a graduate research project. And it's all thanks to KVEC and the grants that we've received, and the help of Dr. Haridas, and the STEAM class. And so we want to give all of our thanks out there to them, because I plan on going into engineering, either mechanical or chemical. And so if I choose the chemical route, this is something that I could continue on in my graduate research and, make a business out of, make a discovery. And so without KVEC and Doc and just like this whole program for Eastern Kentucky, there wouldn't be this research going on like in these schools. Okay, so that's all we have. Do we have any questions or anything? Okay, thank you guys. Thank you for listening.